Hi there, welcome back to the Flask Mastery Series. I'm Gorret and in this session we shall focus on database modeling for the user model using an ORM. So in the context of databases, a model is a visual representation of the structure of a database. It defines how data is stored, organized, and accessed. So for example, on a user model, we can have attributes like the first name, the email, the password, and these attributes form the foundation of a database model, as we are going to see. An ORM is an object relational mapper that simplifies database interactions by allowing us to work with objects in our code instead of raw SQL queries, meaning that we do not directly work with SQL commands like select, create table to interact with the database. So in other words, an ORM abstracts away the complexities of working with database interactions directly. So to put the theory into practice, we shall be creating a simple user model for our API using Flask SQLAlchemy as our object relational mapper. Since we are going to work with Flask SQLAlchemy as our object relational mapper, we shall first of all need to install it. So you can check out the Flask SQLAlchemy palettes, the official docs, and on the user guide, we click on the installation. And for the installation part of it, we can see that the first thing we have to do is to run a pip install -u Flask SQLAlchemy. So you can copy this and paste it in our terminal. So always ensure that your virtual environment is active before running any installation. So I'll click enter. So once the installation is complete, I'll first of all clear this up. And to confirm that Flask SQLAlchemy was installed successfully, we can type a pip list. Then it will go ahead and list for us the libraries that have been installed. So we see that in the previous video we went ahead and installed Flask, and now we have also installed Flask SQLAlchemy. So we are now going to go ahead and create a new database instance. So we shall open our extensions file, and then we import from Flask SQLAlchemy. We import SQLAlchemy. And for us to create the instance, of course, the object must be initialized on this class, SQLAlchemy. So the instance will be db as a variable. Then we call the class using its constructor. So we shall now go ahead and register our database instance in our application factory function. So we shall first of all import it from app.extensions. We import the db variable. Shall say db.init app. Then we pass in our app variable. So this is all for the initialization of our database instance on our app variable. So we now have to go ahead and start building our user. So we are going to go ahead and create a class with name user, and take note that all model names start with a capital letter. So that means that if you create the model with the first letter in lowercase, then you are not following the syntaxes. So since we are working with an object relational mapper, if we create our class user, we have to inherit from the db object such that we access the model class. So we are going to first of all import the db object from app.extensions. We shall import our db object. So db.model. So here we are trying to inherit from the model class such that we have the ability of creating columns that are going to be stored within our table for the users. So by default, whenever we create a model, for example the user model, the table name when you run the migrations is going to be the name that we have defined here. So in other words, it's going to take on the name as user for the table. So most of the times you can always customize this. So I'll go ahead and customize. So the variable we use for customizing is table name. Table name. Then I assign this to users. So whenever you are customizing, that means that the name must be different from the default table name. So for this case, I'm passing in the table name as users in plural. So for the user model, we need the ID that is going to act as our primary key to uniquely identify every user record. So ID will equal to db.column. So the db.column takes in the data type for this column. So if we are defining the ID, so the ID will be of type int. So this is going to be db.integer. And take note that all the data types start with a capital letter. So db.integer, and also the C for the column is in capital. Okay, so db.integer, and then we know that this is going to act as the primary key. So the constraint for this passing primary key will equal to true. So this acts as a boolean, meaning that whenever we pass in this boolean param, it checks whether this is the primary key or if this column is not going to act as a primary key. So for this case, we want our ID to be the primary key, and that is why we are setting the value to be true. Then we shall also need the first name for our user. So first name, so db.column. So the first thing we have to define is the data type for this column. And we know that usernames, for example, Gorret is always a string. So db.string, and you can also pass in the validations for this. Maximum number of characters are going to be 50. And you want to work with the first name in a way that it is always required. So we shall pass in the nullable, and the value is going to be false. So I'll first of all copy this area so that we use it for the other columns. So for the last name, of course, the data type for the last name is also going to be of type string, but we know that most of the times people's last names can actually be more than 50, so we can just update this to maybe 100 characters. And the first name must also be required, so nullable is going to be false. Then we update this to the email, since we also want to keep track of the email address so that we work with it during the authentication process. So email is also of type string, but we can update this to 100. And we know that it's also going to be required. So the constraint for the email, we want to work with the email addresses in a way that they are unique for every user. So we pass in unique will equal to true. So I'll still copy and paste this so that we can just edit. So we shall also need the user contact. So contact. The contact is also going to be of type string, and it must be required, so nullable will be false. But we can also see that for contacts, they are always unique for a particular user. So that means that we also need to work with a unique constraint. So we shall pass in the unique constraint, unique equals to true. And then for the password, since we are going to use it for authentication, we shall work with the text, db.text, and then the password is also going to be required, so nullable will still remain to false. So we know that we are going to be working with the authors, so we can go ahead and also define a column for the biography to cater for the author part. In other words, for user types for the authors. So biography, db.column, then we pass in db.text. So we know that cases whereby maybe we have a user type for the admin, the biography can actually be null. But cases whereby we are working with the author, the biography will be required. So that means that by default, we can pass in the nullable value to be true. So nullable will be true for this case. And we can also define the user type. So I'll just copy this. Actually, I can just copy this user type. So the user type column will be distinguishing the different types of users we are going to work with, because we can have the admin, the super admin, and then the authors. In a way that the admins are going to be managing the author data. So user type db.column, then db.string. So we can pass in a maximum of maybe 20. And then we can also pass in the default type to be that of an author. So we can also work with timestamps in a way that we are storing the time and date at which a new user was created within our system. So for this case, we can work with timestamp columns in a way that we add a created at, and we define this db.column. So the data type for this case, it takes on the date time data type. And take note that the way I'm defining this data type is in Pascal. So we have the D in a way that it is uppercase, and the T also, it's being defined in uppercase. So db.datetime, then comma. So we want to always keep track of the date and time at which each user is going to be created. So this is going to default to. So we shall first of all import the datetime package. So from datetime, we import the datetime. So the default datetime is going to be the current datetime. So datetime.now. And then we shall also do the same for the updated at. So we shall update this to updated at. So db.column, db.datetime. Then the difference here is if it is going to act as our updated at column, we shall use the onUpdate datetime.now. So we are also going to go ahead and create a constructor for our user model, such that in case we create any new instance or any new user, all these fields are going to be automatically generated, and also they will be required. So now for this case, we can go ahead and define our constructor in it. So for now, we shall update this. And you know that this is the base class. So we are going to go ahead and pass in all these attributes that we have defined. So we have the first name, the last name, we have the email, we also have the contact, then the password, then we have the biography, then we also have the user type. We can also actually create a column that is going to store the user image, such that we can also handle image uploading in the future. So image db.string, we can update this to 255. Then it can actually be nullable, meaning that the user image will not be required, especially for cases whereby we are creating a new user. It can be null, and we do not need to pass in the unique constraint. So I also update it to image. So the image by default, it can be none. So we shall go ahead and define all these attributes. Self.first name, assign it to the first name that will be provided. So I'll go ahead and copy this and paste it here, such that we just update. So last name, then we have the email, then the contact, then the password, Then we shall also cater for the biography, then the user type, and then same applies to the image. So we shall also go ahead and create a custom function that is going to be concatenating our user's first name with their last name. So since the function is going to belong to our class, the indentation must be the right indentation. So def, so the function name is going to be get full name, then it takes in the current object, then we shall return. So for this case I will use the F formatter such that we return the user's last name concatenated with the user first name, something like this. So that means that cases whereby we are going to be creating new users, we can always, for example, return a customized response in the message like Nabatanzi Gorret has been created successfully as an author, something like that. So that is it for the user modeling. Thanks for watching and see you again in the next session where we shall be modeling the company model.